So in this video we're going to talk about how to add vectors. And I have 4 examples of how vectors might add together below here. And we'll just go through them one by one to help you better understand how to add vectors. So first off, before you start adding vectors, you need to decide on one really important thing. Which direction is going to be positive vector and which direction is going to be the negative vector. So what do I mean by that? So in this example, I'm going to say that all forces, or all forces going right are positive, and all left are going to be negative. Okay? So this will make a little more sense in the examples. So if I had a 4 Newton force and a 3 Newton force, I would look, and according to my rules about which one I wanted to think about going right, they're positive, and going left they're negative, so I don't have any forces going left. So I would add 4 newtons plus 3 newtons, which are both positive quantities, and you can see this box was being pushed by a 7 Newton force. What about over here? How would we do this one? So let's see, I have a 3 Newton force, and I'm adding it to, okay, so this force over here by this guy right here is going to the left, so this becomes minus 4 newtons because I said that all the forces to the right are positive. That means all the forces to the left have to be negative. And I get negative 1 newton. So this force, this box is experiencing a force of negative 1 newton. So what does that mean? What is negative 1? How can you have a negative force? So that just simply means that the force that it's experiencing is going to the left. So it's experiencing a 1 Newton force to the left. What about this one? So I have a 4 Newton force to the right and a 3 Newton force to the left, so that becomes negative. So negative 3 newtons, and I get 1 Newton. So I see that this is positive again, so I know that this force is to the right. Alright, now for, oh no, what's this? So I have some forces that are not pointing to the, oh, this guy's pointing to the right, but this guy's pointing down. Well, what do I do now that I have the forces pointing not only to the right, but I also have forces pointing down? Well, just like on forces pointing to the left or to the right, you have to assign forces pointing up and down a negative or a positive. So I'll say up is positive and down is negative. Alright. There's one other thing though. These forces aren't pointing in the same direction. So all these other forces were pointing along the x-axis, so they're all pointing left or right. But this one has some force pointing down, this one has a force pointing right. How can we add two forces that are pointing 2 different directions? That doesn't make sense. So let's look. Alright, because these vectors are going in 2 different directions, we need to follow some rules for adding the vectors together. And there's 2 really basic rules that we need to follow. First, we can move the vector anywhere we want because, or the vector arrows anywhere we want, because they're a vector. They have magnitude and direction, but they don't have a location necessarily. So what I've done here is I've taken the 4 Newton arrow and I've moved it down here, and the 3 Newton arrow and moved it right here. So I've added these vectors head to tail like I've done in step 2 of the rules here. Alright, so I have my vectors stacked head to tail like the rules tell me to, and if you'll notice, the 4 Newton arrow is much longer than the 3 Newton arrow. So the length of the vector arrows indicate how much magnitude the vector has, and the direction the arrows are pointing indicate the direction of the vector. Easy enough. So if you'll see, when I stack these arrows like this and like this, what you would expect is that you would get a third arrow that you would actually observe of force pointing down and to the right, kind of like this. And we call this the resultant. And if you'll notice, the resultant is the hypotenuse of a right triangle. So this is a right triangle. And using the properties of right triangles, we can add and subtract the vectors that we have. So whenever you add vectors, stack them head to tail, try to get a right triangle, and calculate the resultant. So how can we calculate the resultant? So the resultant is going to be the length or the magnitude of this vector arrow. And we can do this, because this is a right triangle, by using Pythagoras' theorem. A squared plus b squared equals c squared. Right? So if I have side AB, and it's 4 newtons, and I have side BC, which is 3 newtons, I can square both of these, and I'll get the square of side length AC. So I get 25 equals AC squared. I take the square root of both sides of my thing, and I find that the resultant is 5 newtons. So the resultant magnitude of this vector is 5 newtons, so the box is going to be experiencing 5 newtons. But I'm not done, because vectors have both magnitude and direction, right? So how do I find the direction? Alright, so we can find the direction of our vector by using trig functions. So if you don't remember from your geometry class, the trigonometry functions are sine, cosine, and tangent, right? Sine, cosine, and tangent. And we use the opposite and the hypotenuse of our angle when we're using sine. We use the adjacent over the hypotenuse when we use cosine, and we use the opposite over the adjacent when we use tangent. And because we know that this is 5 newtons here, because we know all 3 sides of our triangle, we can use any of these functions we want, really. But I'm going to choose tangent, DOA, because we were originally given 4 and 3, and so it'll be based on our original information we used. So if I take the tangent of our angle theta, and we get opposite, so my angle is 3 newtons, and adjacent of this angle is 4 newtons, so 3 newtons over 4 newtons. Right. So then I need to take the inverse tangent to find the angle, so the inverse of 3 over 4, and I get, so make sure you take the inverse when you do this, otherwise you will get the right answer. So tangent 3 over 4, I get 36.9 degrees. Okay? So ultimately we have a vector going in this direction, which is 5 newtons at 36.9 degrees. Alright. And that at 36.9 degrees below the horizontal. So in addition to being able to combine vectors by adding them together using our trig functions, we can break a vector into 2 components, its x component and its y component. So if I look at this, what I've drawn here, I have a 15 Newton vector pointing 30 degrees above the x-axis. So this vector, if we pull it out, is made of, so if I have a 15 Newton vector, it's made of, I could think of it as being made of force in the x direction added to a force in the y direction. And this force in the x direction and this force in the y direction are its vector's components. So if I wanted to find the y component of my vector, okay, I'll read this as 30 degrees. If I wanted to find the y component of my vector, I could use our SOHCAHTOA again, right? Our trig functions. SOHCAHTOA. Okay, so let's see what I'm given. So I have a hypotenuse. I have an opposite. And I have an adjacent angle. Alright, so if I'm trying to find Fy, I need to take something that has the opposite in it. So I can see here, sine is opposite over hypotenuse. So if I take the opposite of my 30-degree angle and I divide it by 15 newtons, which is my value of my hypothesis, and that should equal the sine of 30 degrees. Okay, I can then do a little bit of algebra, and I find that 15 newtons is equal to, or 15 times the sine of 30 is equal to Fy, which we can calculate really quick using our calculator, or you can use special right triangles in this case since it's 30 degrees, whichever you prefer. I'm going to use the calculator so we don't confuse anyone and add additional material. I get Fy is 7.5 newtons. Okay? So what if I wanted to find Fx? So Fx, I'm going to draw a line, separate this, the Fx component of our vector. So x is in the adjacent side of the triangle, so I can take cosine is adjacent over hypotenuse, so I can take my Fx over 15 newtons equals, so it's cosine of our 30-degree angle. Okay, so Fx is equal to 15, I'm sorry, I'm running out of room here, cosine 30, which ends up being about 13. Equals 13 newtons. Okay, so that's pretty good. So why would you want to break these numbers into components? Well, it's important to break them into components because if you break them into components, you can add like components of different vectors in order to calculate things in the future in the class. So just for now, focus on being able to break the vectors into components, and we'll use this later on. Thanks.